BC test.
Your first what?
Isn't that crazy compared to my 75 last year?
On your first what test? I still
BC, calculus BC.
Oh, BC. Oh, okay.
Isn't that awesome?
Wasn't it just a review test?
No, it was differential, well, kind of. It was differential equations in Euler's method. But Euler's was easy.
I don't remember it, but...
Really? So you can't help me with BC?
No, I don't know.
You do
I
know.
No.
I didn't know you do.
No, I don't.
Can you reteach me washer method? If I
It's
sign
same
up
as-
for advisory?
It's the same as... It's the easier than disc method.
No, it's not.
Yeah, it
You
is.
have to, no, because you have to find the middle one.
That's washer.
Yeah.
This method's when you don't need to know.
Yeah, I need help with washer method.
Okay, if you can do washer's the easy one.
No, it's not.
Oh yeah, you're right. If you can do the big part as disc and the part that's missing in the middle as a disc, you just
Yeah.
subtract them. So if you can do
But, like,
this
I
method,
can't find the middle part. That's the problem. Because it's like the big R minus the little r. Because it's like
Yeah.
circle.
yeah.
But that's like all I know. I have a fun little packet. Maybe I'll come into your advisory one day next week. Because we get really long packets in BC to review.
Well, honestly, I don't know. There's a lot of BC stuff that I'm not sure I ever did learn. And some of it.
You literally know everything.
No, I don't.
Yes, you do. I assume Yes, you literally know everything. You said someone's doing math, and yeah, that's facts.
When I did Cal 3 and Cal 2, it was like 15, 20 years ago.
But like, no, I know you still got it. I need.
No, I don't.
Yes, you do. I need help. I'm gonna need help. We're about to mark.
You guys go so slow, you'll have plenty of time. You need to worry about the physics. That's
I have a
gonna be
physics
hard.
test today. Isn't that scary? And I have a thing in AP Lit right now, which is also scary. Physics is more scary though. Suman's in my physics class. He's better than I am. He doesn't even know calculus yet. That's okay. We're getting there. We're getting there.
How's everything else?
You know, I'm just waiting for them to announce when that like teacher-student dance is, so I can come make you do it with me.
Not.
Yes, you will. I'm gonna come ask. I don't care. You can say no, but I'm still coming to ask.
Okay. Well,
But yeah, everything else is good. What do we think?
still dating a boy that
I'm
lives in
actually not.
Okay.
But maybe. We still like talk, so I don't know. Yeah, that's confusing. Just wait. He's coming back for Thanksgiving.
You'll find somebody else before then.
Okay. We'll see. We'll see. Okay, I just wanted to let you know that I am doing good at BC. And
Yeah?
I'm doing good
I
at
didn't doubt
physics
that.
right now.
Except that y'all tell Miss Cross
No, I
make
don't.
up
I
stuff
defend
about
you. No, I defend you. I defend you. Let me think of what we talked about you yesterday.
Yesterday.
Yeah, no, we talked because it's the mix now. It's like cross X Townsend. They're all in one class.
Yeah, so?
So like everyone is always comparing. Oh, we were talking about a test or like something or like a curve, and we were like, Mr. Townsend would never let us do that on the test. Like she just gave us the calculator section and the no calculator section at the exact same time.
She trusts you.
I guess.
I didn't trust you.
That's valid. I wouldn't trust us either, because I know people use the calculator on the no calculator part.
And it's usually the people that shouldn't be. So.
True. Okay.
Well, no wonder you got an A on it.
Okay, I wasn't saying I did.
All
I
right.
didn't just get an A, I got 100. But there was also a bonus question, which you also don't do. So,
You know we do the same thing for AB.
you did not give us bonus questions.
Right. She doesn't get bonus questions in AB.
Oh.
In BC she can. She's the only BC teacher, so she can
BC,
do what she wants.
She gave us a
AB
question
we
about,
have to
like,
agree on the same stuff.
movies. Yeah, I guess.
Yeah.
I
But
was
remember,
AB.
she's the nice calculus teacher, so.
No, you're nice, you're just more strict. Like, be so thankful, I'm so thankful I never had you, like, first period. I would have had, like, 10 tardies a semester. It would have been so bad.
You're about to get a tardy today.
Yeah, I'm gonna go. I have to go and write something about
Is
surgery.
Frankie not here today?
She should be. I think she will be. She just got back from Michigan. You should ask her about her fish.
Yeah, she shows me all these photoshopped.
No, they're real. You should ask her about her Michigan fish. They have, like, teeth. They're scary.
I think it's photoshopped.
I don't think so. Okay, Mr. Townsend, I'll come sign up for advising next week so you can teach BBC. Thank you.
Frankie Julia. Thompson. Blake, Zoe. You made it. Thompson. Okay, I guess no minute of silence today. All right, you guys will need a blank piece of paper here in a bit, and the handout that you picked up needs to be numbered as 36. So if you go ahead and do that, and I guess we'll go ahead and get started, but we may get cut off by pledge and the minute of silence here. I don't know what they're doing. All right, so we are moving into Unit 3. So remember, Unit 1 was just a couple quick weeks on limits. Then we've spent the rest of the school year on Unit 2, which was some basics about derivatives, a few applications, things like position to velocity to acceleration, stuff like that. But generally, Unit 2 is all about taking derivatives. So we learned what the definition of a derivative was, what a tangent line looks like, power rule, product rule, quotient rule, chain rule, and then lots of practice to get better at those things. In Unit 3, we've got a couple small things, but realistically there's two big topics in Unit 3. So one of those we are going to knock out today, called implicit differentiation. So we're going to go over the notes on that for 36, and then I've got one Khan Academy assignment for you on that for 37. You'll have plenty of time to get that done in class. And then a book assignment to practice a couple more of those question types, and that you may or may not finish in class, but that'll be your homework if you don't finish. All right. So, right now, you have only learned how to take the derivative of something explicitly. So on our notes here, this is somebody working out a derivative question explicitly. And notice this looks a little bit different. It's got the x's and the y's kind of switched up. So to take a derivative explicitly, you would have to take this equation, solve it for y equals. Then when you take the derivative of the left side, you get dy dx, or y prime, same thing. And then because you solve it for y equals, when you take the derivative of the other side, looks like they did power rule, and then the negative 2x was from chain rule, and then they got the answer. This is perfectly fine sometimes, but sometimes it's easier to do implicit, and some questions, like some of the examples we're going to look at on this one, have to be done implicitly. So the thing that I have told you in the past, I omitted one thing because it didn't matter at the time, but what is the derivative of x squared? Okay, it is 2x, and then technically, the part I have not been telling you is that we just took the derivative of x with respect to x. The way you write that is dx over dx. X was the variable in the question, and x is the independent variable. Now, this isn't really like a fraction, but it works like a fraction. And notice anything divided by itself is like 1. And so because that became 1, it didn't matter, and we haven't had to talk about that at this time. But now it is going to matter. So in this implicit example, they're taking the derivative of y cubed with the power rule. They brought the power down, lowered the power by 1. But then they have to come back and say, well, I took the derivative of y was the variable, with respect to x. All of these will be with respect to x. Over here, they took the derivative of x squared to get 2x, and then they said, I just took the derivative of an x with respect to x. Since dx over dx is like 1, it basically goes away in the next step. But dy over dx doesn't go away. This is the derivative of y with respect to x. In fact, that's what they are trying to solve for. That is the derivative. So, implicit is really just one step that you need to consider, and it's this right here that I'm about to highlight. Any and every time you take the derivative of y with respect to a different variable, and today it's always with respect to x, you have to put this dy over dx or y prime, same thing. This is the same thing as y prime. In fact, that's what you're trying to solve for in this question. So if you forget it in this question, you're never going to be able to solve for the derivative. And it is a little harder to see, but this is basically a chain rule property. Because when you take the derivative of y cubed, it's like the inside is y, and so the chain rule says take the derivative of the inside, which is where the dy over dx comes from. Okay, so let's go through a few examples here so you can see how this is different than you've done in the past. Okay, and once we get to the other side, you won't have to write as much of this. But for now, I want you to write all the stuff that I'm writing. The derivative of x squared would be 2x. But go ahead and put that we took the derivative of an x with respect to x. X was the variable. Then we can take the derivative of 5x, which would be 5. And once again, I took the derivative of x with respect to x. And then to do this one, we're going to use the same old rules we've been practicing for a few weeks now. It's just a power rule. Bring the power down, lower the power by 1. But this time, I took the derivative of a y with respect to x. This one's important. Okay, 3y would be 3. And then once again, I took the derivative of a y with respect to x. So we have to put this dy over dx. The derivative of a constant is 0. And if you take the derivative of the left side, you have to take the derivative of the right side. But the derivative of 0 is still 0. Now, the part of this that you don't have to do once we get to the back page is most of this just goes to 1. dx over dx is like 1. So 2x times 1, 5 times 1. But if it's a dy over dx, you absolutely must keep that. And you can leave it looking like this, dy over dx, or you can make it look like y prime. Those are exactly the same thing. And then here, I also took the derivative of y with respect to x. So it had a y prime. So if this question is asking you to find the derivative, well, there's the derivative that's highlighted. The highlighted steps are the only thing that's new. If you forget the dx over dx, it doesn't really matter because it ends up being 1. But every time you take the derivative of y, you need a dy over dx. Every time you take the derivative of y, you need a dy dx. Now, we still need to solve this algebraically to get the derivative, but from here, most of the questions simplified the same way. So we could subtract this 2x over, we could subtract the 5 over. Oliver, you need to be getting this down on your paper. We're on example 2. If everything on the left side has a y prime in it, you could factor that GCF out. And then finally, you can undo times with divide. The nice thing is the algebra of keeping all the y prime stuff on one side, move everything else to the other side, factor out a y prime. undo times with divide. That's pretty much in every single question, but the highlighted steps are the ones we need to focus on. And then here's our derivative. Y prime, the derivative is equal to this. That's what we're searching for. Okay, let's look at example 3, right below it. So when I take the derivative of x squared, we're going to still do that the same way, 2x, and then at least mentally, and for this side of the page, once we get to the back side, you don't ever have to do it again, but you need to be thinking I took derivative of an x with respect to x. This piece, this part's a little more complicated because this is an x times a y, so we have to use product rule. We could take the derivative of x, which would be 1 dx over dx times y left alone, plus, and then x left alone times the derivative of y. And because I'm taking the derivative of y, I absolutely must put the dy over dx. Then for 3y squared, just use the regular power rule and then catch that you just took the derivative of y with respect to x again. So we need another y prime. And you can't take the derivative of the left side without taking the derivative of the right side and keeping it balanced. So it looks a little more complicated than it really is because I'm asking you to write down this dx over dx, but this is like 1, so this is like 2x minus 1. If I distribute this -5, this is like -5 times y. And I distribute this is like -5 times an x times a y prime. And here we've got a 6y and a y prime equals 0. So there was 2 times I took the derivative of a y, which is why I have 2 y primes. If you forget it even once, then you're going to be real confused because your answer is never going to be off right, or never going to be correct. Now, to actually solve for the derivative, again, these are pretty formulaic. Move this stuff over. Subtract the 2x, add the 5y. If both of these have a y prime, you can factor it out as a GCF, and then you can undo times with divide. Again, most of these finish the same way, so that would be the derivative. So it's not really a hard step to input these y primes. It's not too hard to see when I should be doing it and when I shouldn't be doing it. But like a lot of things in calculus, you just have to practice it a handful of times so that you think about it every single time. Even doing it once here would not be sufficient. You have to get both of them. Okay, let's look at 2 more, and then I will have you try one on the top of the next page. So x cubed, we're still doing it the same way, but at least mentally we're thinking about we took the derivative of x with respect to x. Y cubed, we can still do the same power rule we've always been doing, but you have to realize that you took the derivative of y with respect to x, so you need a dy over dx, and the derivative of 8 would be 0. So this one doesn't matter because it's like multiplying by 1, but this one absolutely does matter. In fact, in this question, if you forget that, you're never going to find the derivative because that's the only place where the derivative showed up. So that's what we're trying to solve for. Every time you take the derivative of y, you need a y prime. As long as you remember that, you can do implicit. Okay, and then I could subtract this over. Undo times with divide. And I guess, I don't know, you could probably at least cancel out the 3's. But that would be the derivative. Now, before I give one more example here, I do want you guys to realize, like, some of these equations here are so complicated I couldn't begin to sketch them. But it's good for you to understand why there's an x and a y in some of these derivatives now. By the way, these are not functions. They don't pass the vertical line test. But like if we were looking at this one, this represents a circle with radius 3. So if you did implicit to solve for the derivative, this derivative should have an x and a y, because if it only has an x in it, and I want to know the derivative when x is 2, well, I also need to know what y is, because x equals 2 could be here, this negative value, or here, that could be this positive value. So that's why some of these derivatives will have an x and a y, because we need to plug it into both. Or we need to plug in x and y to know exactly which point we're talking about. But again, not a function. But sometimes these conic shapes like this, we still want to know the slope or the instantaneous rate of change. Okay, one more before I ask you to try one. This one is a little bit different because it gives us a point, which actually makes it a little bit easier, I think. But we're going to take the derivative of y the same old way we would take the derivative of x. It would be 1. But you have to put a dy dx. For this one, we would have to use product rule because we've got x squared times y. So take the derivative of x squared with y left alone plus x squared left alone times the derivative of y. That would be 1. But once again, I took the derivative of y, so I need another y prime. And then the derivative of cosine is negative sine. So in the end, this is, again, you're welcome to keep dy over dx the whole time if you want to, but y prime is exactly the same thing. So to me, this is just a little cleaner looking. If I distribute this, I get minus 6xy and a minus 3x squared y prime. Now, when I ask you to do the Khan Academy after these notes, some of the Khan Academy questions are like this one, where it gives you a point instead. So if you want to take a few steps, solve for the derivative, and then plug in the 0.01, that will work. But this is really unnecessary. You don't have to solve this for what the derivative equals if you have a point. If you have a point, just start plugging this stuff in. Everywhere there's an x, plug in 0. Everywhere there's a y, plug in 1. Now, y prime is not the same thing as y, though, so you've got to leave those alone. But if I plug in a 0 for x and a 1 for y, notice most of it just goes away, especially when part of it is 0. And it looks like our derivative at this time, at 0, 1, is negative sine of 0. And what is the sine of 0? Good. And 0 times negative 1 is 0. So that graph there, not even a function, but it looks like if you looked at the point where x is 0 and y is 1, at that moment it has a horizontal tangent line because it has a slope of 0. So again, you're welcome to solve for y prime equals and then plug in the point, but it's more work. Pretty much you can just throw that point in after you've done implicit differentiation, and you can see it usually cleans up pretty quickly. Okay, I would like you to try this one on the back, if for no other reason to see where you slow down or what mistake you make. So let me give you just a couple minutes here, see how far you can get. Then I want to show you what this looks like, often looks like on the AP exam, and look at part of a past FRQ. And then you guys will be a little bit more at your own pace after that. So I apologize if that's not enough time, but again, you'll get to practice a handful of these questions today. So now that we're on the back side, I'm not going to require that you write this anymore, but when you take power rule here, you should get 8x, dx over dx, which doesn't matter because that's like 1. But here, when you did power rule, you absolutely must have put a dy dx because you're taking the derivative of y with respect to a different variable. They'll all be with respect to x today. And if you take the derivative of the left side, make sure you take the derivative of the right side. But that one thing to think about is really the only thing that makes implicit different. Now, of course, simplifying still takes some practice. Some questions are going to take more steps of simplifying than others. But it looks like it should come out to be, if you reduce x over y. Oh, I missed this, yeah. So negative 18. Let's see, that still reduces a little bit. Could divide both by 4, negative 4. No, not 4. By 2, negative 2. That look better? So again, not necessarily hard, but we have to be consistent. We have to remember it. Every time we take the derivative of something with the y in it, we have to include the y prime. And again, I know it's hard to see, but it really is just chain rule. Y is the inside part of this. When you bring the power down, lower the power by 1, and then you consider the derivative of y, the change in y with respect to x is probably not 1, whereas with the change in x with respect to x is always 1. So that's why we haven't needed it up to this point. Okay, so as I said, implicit is one of 2 big topics in Unit 3, and they do sometimes ask these question types in multiple choice, but they also often ask them in FRQs. So we have finally gotten to the point in the year where you guys have seen enough calculus to where you can see a real FRQ now, not one that we just kind of had to piecemeal together to make it look good. But I picked this one because part A is implicit, and I want you to see how they often ask you guys to do this on the FRQ. And I want to just briefly talk about parts B and C because, well, partly I need you guys to see that you already know the calculus behind parts B and C, but the free responses are definitely the hardest part of our AP exam. So we have to start practicing some of those tough ones for them to ever get easier to us. So I will go over parts B and C as well, ask you to copy it along, but I'm not going to spend too long on them. Mostly just kind of point it out to you and show you what it looks like. All right, but part A, when they ask you to do this in an FRQ, they usually just tell you what the answer is, but they expect you to show that it's the answer. So I don't know, I would think if I was in y'all's shoe, you would be happy to see this on there because you know, unless you just run out of time or something, you know what you're aiming for. So let's go ahead and do implicit differentiation to this. So the first piece would be 6y squared. I took the derivative of y. Over here, we would have to use product rule. X squared times y is product rule. So take the derivative of x squared with y left alone, and then the derivative of y with x squared left alone. Then the derivative of negative 12x squared. Then the derivative of 6y. Once again, I took the derivative of y. And make sure you take the derivative of the other side as well. So sure, the part in red is product rule. It's a little bit messier, but you've at least had some practice with that for a little while now. But I've got 3 y primes. And y prime is the same thing as dy over dx. So if I can solve this equation for y prime equals, it should equal this, and then I should be getting both of the 2 points that they give you for this. So as far as the algebra goes, I would probably distribute this 6. And then, like the questions on the other side of this page, anything that is not a y prime can just be subtracted over to the other side, like the 12xy's and the minus 24x. You gonna do this later? Oh, you got it. Okay, I didn't see it there. That way, if everything on the left side has a y prime, we can factor it out as a GCF. Now the important part here is that you're showing all your steps. They're not interested in the answer, they're giving you the answer. You need to make sure that you have the work that matches up. Undo times with divide. Now, if you look at their answer, what does it look like they may have done to all of this stuff to make it look like their stuff? I'm sorry? I still can't hear you. Okay, but how so? Okay, so these two have a GCF and all of these have a GCF. Do you guys see how you could pull out a 6 out of this and a 6 out of this and divide those out? Or you can just divide everything by 6. So I'm going to divide this by 6 and put it first because they have it first in their answer. That's okay to do as long as you divide this by 6 and divide this by 6 and divide this by 6 and divide this by 6. So pretty common. We look at a lot of FRQs, especially as we get close to the AP exam. But pretty common that they say, do implicit, here's the answer you should be aiming for, and you need to have the work that shows how to get that. So the scoring on this one, I always like to share the scoring with you guys because even on the hard questions, when we go through B and C here in a second, it's good for you to see that some of the points are very manageable. Some points are usually pretty hard to get. But on this question, they give 1 point if you did all this implicit right. So if you just remembered the y prime 3 times, you got 1 point. Remember, FRQs are always out of 9 points. And then 1 point if you showed the work and got to the answer that they asked. So part A was only worth 2 points. But even after today, you guys should feel fairly confident on that. So those 2 points are pretty achievable. Now, since this is our new topic, is there any questions, clarifying questions, anything about part A before we just glance at B and C? Yeah.
Do you have unlimited paper for this?
Unlimited paper? On the AP exam?
Yes, for that part.
Usually it's like they'll have the question on the top of the page, and then like you'll have half a page for part A, half a page for part B, half a page for part C. You have tons of space. Okay, any other questions about part A? Okay, so again, I don't want you to stress out about part B or part C, but it's important for you guys to see that you already know the calculus behind this, but it's good for you to see that some of the times when they ask these questions, they're not super straightforward and they take some thought, which is why it's so important to know the basics to buy yourself more time for these other things. So part B says write an equation of each horizontal tangent line to the curve. Well, when I see horizontal tangent line, we've already talked about when that occurs. When do you get a horizontal line? Okay, so in calculus, instead of saying slope, we're just going to say derivative. So when the derivative equals 0 is when you're going to have horizontal tangent lines. And as messy or as tough as this question is, you get 1 point if you write that down, that you realize that horizontal tangent line has to occur when the derivative equals 0. Okay, but to do the work, they gave you the derivative in part A, so even if you couldn't do part A, you should still have a fighting chance for part B and C, although I think A is the easiest part. Set the derivative equal to 0, but by the way, if you don't know that, if you haven't memorized that yet, then you can see how you're stuck on part B right away. Okay, when does a fraction like this equal 0? Okay, so when the numerator equals 0. This is where it's not calculus, but it's still uncomfortable. To solve this, you might need to recognize that these two both have a GCF of 2x. And we can solve this. You guys are used to it looking like this. If this times this equals 0, it could be where this equals 0 or where that equals 0. Well, same thing here. Where 2x equals 0 or when 2 minus y equals 0. That would be when y is 2. So with that work, we have figured out where the derivative is 0, because that's where you'd have a horizontal tangent line. And you get 1 point if you made it that far. But it didn't ask for that, it asked for an equation of the tangent lines. So if I take this value, x equals 0, if I plug that into the original problem, if I plug 0 into the original problem, I'm left with this statement. And we could use a calculator to solve this. You could either do the equation solver or you could do it from the graph like we did on that circuit a couple weeks ago. And this is true when y is 0.165. From here to here, I would have to use a calculator to solve that. But that's the case when x equals 0. If you do the case when x or y equals 2, you end up with 16 plus 12x squared minus 12x squared plus 12 equals 1. I'm plugging 2 into the original equation at the top. But the problem here is the x squareds all go away and you're left with a statement that is not true. So this doesn't give us any more horizontal tangent lines. But we have to show that we did that to get a point. No, actually you get 1 point if you showed that you don't get solutions from this, and 1 point if you show you get a solution from that. So again, not easy, not real clear what they want you to do, but the real only calculus that you have to know to start off is horizontal tangent lines have a slope of 0, plug in 0 for the derivative, and then start to try to solve. You have to know that first part very, very well. You don't want to be thinking about this for 2 minutes just to start this. You want to do this in 10 seconds so that you have more time to buy time for that. Okay, and then part C can be done a few different ways, but so there was 4 points in part B. 1 if you just said the derivative has to be 0. 1 if you did that and solved. 1 if you solved it this way correctly with the calculator. 1 if you solved this and showed that it didn't give you 1. 4 total. And then the last part of this FRQ from 1998 says the line through the origin has a slope of -1, is tangent to the curve at point P. Find the x and y coordinates of point P. So at some point you need to use that it goes through the origin with this slope. guess you could do slope-intercept, or you could do point slope, but that's the line that's tangent to the curve at point P. And so we can use this relation for every y. It's the same thing as negative x. So there's two ways you could go here, so I don't know which way you guys prefer, and this isn't important enough to do both methods today. But when it says the slope is -1, what does that also mean? Okay, so you could set the derivative, which was given to you in this problem, equal to -1. You could multiply both sides by the denominator, so you don't have a fraction. But then this is where this comes into play. You can't solve this numerically for x and y. One equation that have x's and y's is not enough. But if you use this and substitute it in, so everywhere there's a y, we put a negative x. Everywhere there's a y, we put a negative x. Then we get a statement that looks like like this. And I don't know how bad this would be to solve by hand, but since we needed a calculator on that part B, I'm guessing this needed a calculator as well. So you could do equation solver or graph this and look for intersects, but this is true when x is -1/2. And then once you know the x value where that occurs, you have to plug that into the original function with the calculator, solve for y, and it becomes +1/2. So you need to see that you got to do all of that to get the last point. At some point when you make this substitution, that was worth a point, whether you did it correctly or not. But the easiest point was this guy right here. When it said the slope was -1, if you showed that you set the derivative equal to -1, that was worth a point. So some points are not too hard to come by. Some points are pretty tough and take several steps. But as we see more and more of these as we go throughout the year, you guys need to make sure that you're writing down the first steps. Even if you know in part B, horizontal tangent lines have a slope of 0, don't just skip to this. Say, I know the slope has to be 0, because that's where a point came from. So once again, not new calculus there, but you guys need to appreciate algebraically how difficult that can be and how much time you might need to sit there and try to think about what they're asking you to do. It's not automatic. So have I talked to you guys about how much time they usually give you on an FRQ? Okay, you get 15 minutes on average. So when you get 2 FRQs, they give you 30 minutes, and when they give you 4 FRQs, you get 60 minutes. So that's why part A, the implicit, you've even got the answer. You want to be able to knock that out as fast as possible. You want to be able to start B and C as fast as possible, so then you actually have some time to try to figure out and work through one that you may not have seen before. Okay, that's all I need to say about that. So again, I just wanted to kind of show you B and C. None of that is relevant to today's topic. So the next piece is you will need a blank piece of paper. I don't mind if you do 37 and 38 on the same page, but you will need a little bit of scratch paper for the Khan Academy. And that one should be due before you guys leave, because you've got 50 minutes to do it. And you just got to get 4 right in a row. So of course, being on Khan Academy, if you miss one, don't just keep going. Click the Get Help, see what you did differently, learn from your mistakes so that you don't continue that mistake. But then if you're not sure, then you need to ask a neighbor or ask me. And of course, some of you guys are going to be done with that in about 5 minutes. Just takes longer for some people, and that's perfectly fine. But as you guys finish, you can move on to the book assignment and practice a few more. What you don't finish from the book is what I will ask you to do for homework. So in your interest to chip away at that as fast as you can.
Would this work as a generalized equation for the parameter of a function x? This
The perimeter of what?
a function, like any function f of x? Like this.
I have no idea. That's not what we're working on right now.
I was just wondering.
I would have to think about it for hours.
It feels like it would, I'm not sure. Kind of like a mixture of a derivative and Riemann sum.
I will be coming around to help out, but at this point you should either be getting them right or at least comparing your work to the Khan Academy work to see what you did different. So.
need help with one, call me afterwards and come around.
Is anyone at a point where I can help? Do what? The one on Khan Academy, and then book assignment. Yeah, once you guys finish the Khan Academy, you're welcome to move on. I encourage you to move on. That way you get more done in class, but... you're doing a whole lot there in one step. It's a little dangerous. Chain rule implicit and floating synchronous. It's a lot to pass. You might try to break it into small pieces. Anybody else got something that can help you? Again, you're more than welcome to put 38 on the same page as 37 if you'd like to. But I do, as always, think it's important for you guys to be making some notes, circling the steps you missed. If there's something that wasn't obvious to you or some kind of mistake you made, you should try to summarize it on your page so that you can look back at that page in the future and remember what it was that wasn't obvious. That's exactly the type of stuff you need to review in the future. Bless you.
Oh, I'm sorry.
You can go.
Okay, hold on, let me check that. Looks good. That's why I left it alone. And right here, check the derivative of y. You didn't put a y prime here. So you put the y prime on that spot. And then let's see here. Okay, so now any of this stuff that doesn't have a y prime, just subtract it over to the other side. And, yeah, get 2x. What happened to get 2x? Okay, I just want to sure it's positive. Like this guy is being multiplied by y prime, so you can't, don't subtract that over the you come up with the same type of thing. Just all the stuff without a y prime. Okay, so now the only thing that's left on the left have a y prime, so you can factor that out as GCF. And then undo that times and all that stuff with divide. And it looks like they might have factored out the negative out of the numerator, but it looks like that should be towards C up there. Yeah, everything you're doing is fine, it's just right here you forgot. You did it here, but you didn't do it there. Every time you gotta have that. Okay, so it's gonna be 2 times, so we can just put the 2 out front. This is one less thing to worry about. Derivative of the cosine function is, okay, so negative times something. So it's gonna stay 2y. But then because of chain rule, we need to do the derivative of the inside. And the derivative of the inside would be 2. Still forgot something. When we're doing the chain rule here, and you're taking the derivative of 2y, so you need another y prime, because you took the derivative of y. That was it.
You need to sign out and take the pass. Just anywhere, just put your name on the board. It's just so if you forget to bring my pass back, I know who to tell the office, because they don't like to make us extra hall passes, so. Okay, you guys still have about 15 minutes. If you keep making some mistakes and you don't finish the Khan Academy in class, you can technically still do it until the start of next class. But you will also have to put in some extra time to catch up on the book work that everyone else is working on. One thing I might suggest on the book work is if you don't think you will finish in the next 15 minutes, you might want to take a page of the questions and maybe a picture of the question page and maybe a picture of the answer page in the back of the book, just in case you have some time in advisory, depending on what y'all signed up for today, or tomorrow for that matter. That way you could maybe work on it if the opportunity presented itself. But the book questions, all of those have been worked out on the website as individual videos, so you can at least get help with those outside of class. But if you think you need some questions about the Khan Academy, you need to let me know in the next 13 minutes before you're out here. Oh, I guess also, instead of taking a picture of the book, you could go to Google Classroom. If you remember, I uploaded the whole book on Google Classroom, so it's a big file and it may not work for you. That's why I asked you to try it earlier. But that could be a possibility too.
for the place to stop at. Which I could multiply by x.
Okay. Okay. Why y prime? Okay, well, the first time when you took the derivative of cosine something, you got negative sine something. So you didn't really, well, I guess you did, but where the y prime comes in is chain rule. And then inside of that was 2y. But the derivative of 2y is not just the y prime. It would be 2y prime. So, you just lost a 2 in there. Yeah, so now times the derivative of the inside, which was 2y. So, and then still equal to 0. How is chemistry going? And then what you said you were excited for this year?
Probably not.
Huh? I think that's what you put on the first day sheet. You're excited about chemistry.
Yeah, that changed.
Right. We are down to about 5 minutes here, so you need to find a stopping place. Again, if you did not finish the Khan Academy, technically it is not due until the start of Thursday's class, so you have time to keep trying at it. But the book assignment is also homework, so hopefully most of you guys got pretty far through that, so you have little to do. But I need you to do that between now and Thursday as well. And then we'll still practice a little bit of implicit, but this is the main thing. So we'll do a few more times, and of course on the test review. But you've really seen all you need to about implicit. Just a little bit more practice will be good. And then the main thing we'll look at next class is related rates, which is a lot of geometry. So hopefully you guys liked your geometry.